Hello everyone, myself Ankit Verma. Today we will discuss our next topic, that is IPv6 or Internet Protocol version 6. Now IPv6 is the advanced version of IPv4. In 1990, IETF started work on new version of IP which would never run out of address and would solve a variety of other problems more flexible and efficient. For that, IETF issued call for proposals and the discussions. After various discussions and meetings and modifications, a combined version called SIPP, that is Simple Internet Protocol Plus, was selected and given designation as IPv6. So first of all, we will discuss the structure of IPv6. Well, the structure of IPv6 consists of 16 bytes or the octaves, and it is of 128-bit long. Now, how to represent the IPv6? We have a hexadecimal clone notification to represent the IPv6. So let's talk about it. Now we'll discuss the hexadecimal clone notification of IPv6 address. The IPv6 address is of 128 bits and is divided into 8 sections, each of 2 bytes in length. And for the 2 bytes in hexadecimal notation, we require 4 decimal digits. So now the IPv6 address consists of 32 hexadecimal digits, which every digits have the 4 digit and separated by a particular column. So that means 128 bits is equal to 16 bytes, and as we have the block of 2 bytes, so that means we require 32 hex digits. Now to understand the hexadecimal clone notification, let's take the diagram. Suppose we are having the 8 blocks of the IP address of IPv6 that is started with of 2 bytes. 2 bytes, that means we have 8 multiplied by 2, that means 16 bits. So first block will be of 16 bits. So that is of 16 bits. This is my first block, and my last block is all ones. I am now going to represent the middle bits. Now this is in the binary form. Now we are going to represent the particular binary form in the hexadecimal form. Now my first block stands for FDEC, in which my first FD, that is the first byte, and second EC, that is the second byte. So that means it is a combination of 2 bytes. Then we have 0074, 4 times 0. Again we have the 4 times 0, again 0. Then we have B0FF and odd ones. That means the 16 times 1 can be represented as FFFF. As we know that the first block, that is complete of 16 bits, which is equivalent to 2 into 8 bits, that is 2 bytes. So that means my first block FDEC, the first 2 FD is 1 byte and again EC is of 1 byte. So that means the combination is equal to the 2 bytes. Now 2 bytes, again 2, all are of 2 bytes. So our IPv6 address is of 16 bytes and each particular block is of 2 bytes where we need 16 bits to represent a particular block. Now next we have the abbreviation and the hexadecimal clone notification. Now the next in the IPv6 we will discuss the abbreviation. That means a particular IPv6 address can be abbreviated. Now for example, we are having the above IP address which is given as the IPv6, and we are having the 8 blocks, 16 bytes. Now 0 can be abbreviated. For example, we are having the 40 every time. I am going to repeat 40 again and again, so I can just remove all the leading zeros and provide a simple address in the IPv6 as mentioned in the diagram. Now I am removing all the zeros, only the leading zeros, not the trailing zeros. That means FDEF will remain same, FDEC will remain same. Then I am removing the leading 2 zeros of the 0074, I am taking only the 74. Then again all the 4 zeros as a single zero, again single zero, BOFF, that is single zero, and all the F. So all the leading zeros are removed. Now, there is one more abbreviation by which we can compact the IPv6 address. That is, for example, we have the continuous zeros, then we can represent with a particular column. Now, FDEF will remain same. Now, FDEC will remain same. Then 74. Now, we are having 3 continuous zeros and we will represent as the column. Then after the column, we have the B0FF, then again 0, then 4F. So my first address is abbreviated and second one is more abbreviated. And the gap is represented by the column. So we have a next question is our mind that how to represent the IPv4 address in IPv6. So the IPv4 address can be represented in IPv6 as the column, then a particular IPv4 address. In the IPv4 address, we have provided the prefix as column, then maybe any of the address, just like 192.168.63.71. So that is the abbreviation and hexadecimal flow notification of IPv6 address. Now we will discuss the address space of IPv6. Address space is the space which is utilized by the particular IP or the protocols, and we know that the address space formula is 2 raised to the power n, where n is the number of bits, and here in the IPv6 we are having the number of bits as the 128, so is equivalent to 2 raised to the power 128. So we have 2 raised to the power 128 addresses in IPv6. So we have discussed the address space. Now we will take the example of a numerical by which we will understand the IPv6 address. Example, you have the numerical in examination to expand the particular address, and you have to expand the particular address from a normal given to the original one. So expand address which is given. Now we have to expand the address to original. For example, we have given an address that is 0.15 colon 1.12.1.3. So we have to expand the particular address to the original IPv6 address. Now, first of all, draw a dummy IPv6 address. So this one is my dummy IPv6 address. Now I will write one by one. So example, the first we have the 0. Now first I will take the 0, then 15. Then as we have the double column, so I will skip all the fields and start from the last. 1 to 1, 3. Previous one we have the 12. Then previous we have the 1. Now again, in the third step, I will replace all the blank fields with a 0. So replace all the blank fields with 0. 4 times 0. 2 zeros. 4 times 0. 4 times 0. Again 4 times 0. 3 times 0. 2 times 0. So now this is my original IPv6 address. So this is my original IPv6 address. And this one is my compact IPv6 address. So now we will discuss the IPv6 header. So next in the IPv6 we will discuss the header. So we will start with the IPv6 header. Same as the IPv4, IPv6 has a particular header which is of the length 32 bit. So now we are going to draw the complete header of IPv6. So now the IPv6 header is of 4 particular rows. In the first row we have the first field that is called the version. We represent this as the VER. In the next field we have the traffic class, then flow label. So in the second row we have the first field that is payload length. Then is the next header. Next one is hope limit. Now in the third row we have the source address, and in the last row we have the destination address. If we are talking about the length of the header header is of 32 bit. Now this is the complete header of IPv6. Now we have the various fields just like version, traffic class, flow label, payload length, next header, hope limit, and the further addresses. So we will start with the version. If you are talking about the version, we are using the IPv6. So version field will always be set as the 6 for IPv6. And if we are using the IPv4 header, the version field will be set to the 4. Next we have the traffic class. The traffic class is used to distinguish between packets with different real-time delivery requirements. Next we have the flow label. Flow label allows source and destination to set up pseudo connection with particular properties and requirements. Now we have a new term that is pseudo connection. So what do you mean by the pseudo connection? For example, we are having a particular source and destination, and they want a separate connection with the specific properties, and nobody else will interrupt them in that particular connection. That is called the pseudo connection. So flow label allows the source and destination to set up that particular pseudo connection or the specific connection with their own requirements or their own properties. So now the next we have the payload length. Payload lengths tell us that how many bytes follow the header. Now every packet has some particular header as well as the data. Data, that means the payload length. In every packet we have to provide a header, and header is provided by IPv6, and the particular data length is provided by payload length. So the next we have the next header, that means to whom the packet passed to. So next header represent to whom the packet passed, that means the next address to whom the packet will be sent. Now the next one we have the hope limit. Hope limit is same as the time to live, and it keeps packet from living forever. And the next we have the source address, that means from where the packet of IPv6 was sent, and the destination address, that means to whom the packet will be received. So that is all about the IPv6 address, which is of 32-bit. Now we'll discuss our next topic under the IPv6, that is advantages of IPv6 over IPv4. Now we have the various advantages of IPv6 over IPv4. So we'll start with the first advantage. IPv6 has the larger address of 128-bit, but the IPv4 has the address of only 32 bits. Now the next advantage is simplified header. The header of IPv6 is of 7 fields, but the header of IPv4 is only 13 fields. So that means the header is very simplified of IPv6. Well, we have the improved throughput and delay in the IPv6. Why? Because we have the small header, and if the router gets the header of IPv6, it can easily pass. So the throughput and the delay is less and improved in IPv6. Now the next advantage of IPv6 is it is having the better security, authentication and privacy over the IPv4. And the next we have the better quality of service of IPv6 over the IPv4. And the next we have the better support for new options. So that means the IPv6 has the more features over the IPv4, and they are having the various advantages of IPv6 over IPv4, like the larger address, that means we can send more data, simplified header, that means that is easy to handle, improved throughput, and delay is very less, and obviously we are having the better security, authentication, privacy, better quality of service, better support for newer options. That means we can also update the IPv6 with our current time. So that is all about the advantages. Next we have the IPv6. Now the IPv6 defines 3 types of addresses. In the first we have the unicast, then we have the anycast, and the third we have the multicast. Unicast and multicast we have already discussed in our previous chapter, that is the casting techniques, but we will discuss again now. The unicast, that means the packet can be sent to the single machine, that is the point-to-point communication. Now the next we have the anycast, that means the packet can be sent to the nearest one. Nearest one, that means which have the shortest route or the shortest distance from the sender. And the next we have the multicast, that means the packet can be sent to each machine of the group. Now we have the specific group in which we have the every machine will send data to each of them. So that is all about the IPv6. Thank you.